Hello everyone, this is Preeti Singh once again in front of you to explain class 11 geography topic interior of the earth. Today I am going to explain you the remaining topic of the interior of the earth. Let's start from the topic effects of the earthquake. There are different kinds of effects which we have to see due to the earthquake like ground shaking, destruction to houses and buildings, landslide and tsunami, soil liquefaction, fire accidents, and destruction to transport and communication lines. Next is the emergence of shadow zones. Meaning of shadow zones. When earthquake takes place, all the places on the earth's surface do not record the seismic waves. There are some zones where seismic waves P and S waves do not reach during an earthquake. It is called as shadow zone. Shadow zones are formed due to two reasons. Three layers in the earth, varying density of each layer, liquid condition of the mantle. Next is P waves shadow zone. Ideally, seismic waves should move in a straight line, but due to varying density of layer, P waves move in a curved path. Due to this, an area around the earth does not record P waves. This zone is from 105 degree to 145 degree from the focus. Next is S waves shadow zone. It is larger zone than P waves shadow zone. It developed because S waves does not pass through liquid mantle of the earth. Therefore, the zone from 105 degree all around the earth from the focus is called as S wave shadow zone. Next is emergence of shadow zone. How and why the shadow zone emerge? Where earthquake waves are not reported, such zones are called earthquake shadow zones. It is observed and seismographs located beyond 103 from the epicenter do not record the earthquake. Seismographs located beyond 142 degree again record P waves only. The entire zone beyond 142 degree do not receive S waves. The shadow zone of S waves is much larger than the P waves. It is equal to 40% of the earth surface. Next, I am going to explain you the layers of the interior of the earth. First, the crust. The crust is the outermost solid part of the earth. The thickness of the crust varies under the oceanic and continental areas. Oceanic crust is thinner as compared to the continental crust. The continental crust is thicker in the areas of major mountain systems. The crust is made up of heavier rocks having a density of 3 gram per centimeter cube. Next layer is the mantle. The portion of the interior beyond the crust is called the mantle. It is in a solid state. It has a density higher than the crust portion. The thickness range from 10 to 200 km. The mantle extends from Moho discontinuity to a depth of 2900 km. The asthenosphere is the upper portion of mantle. The kind of rock seen in the oceanic crust is basalt. The mean density of material in the oceanic crust is 2.7 gram per centimeter cube. Silica and aluminium are major constituent minerals, hence it is often termed as Sial. Also, sometimes Sial is used to refer to the lithosphere. It is the chief source of magma that finds its way to the surface during volcanic eruptions. The crust and the uppermost part of the mantle are called the lithosphere. The major constituent elements of the mantle are silicon and magnesium, and hence it is also termed as sima. The next layer is core. The core mantle boundary is positioned at the depth of 2900 km. The inner core is in the solid state, whereas the outer core is in the liquid state. The core is made up of very heavy material, mostly constituted by nickel and iron. Hence, it is also called the Nife layer. Next topic is volcano. There are differences between active, dormant and extinct volcanoes. First of all, we understand about active volcano is a volcano that is currently erupting or shows signs of unrest activities like earthquake activity or significant amounts of gas discharged. It is a volcano that is not presently erupting but has erupted in the past, is considered likely to do erupt in the future again. Next is dormant. These volcanoes are also called sleeping volcanoes because it is presently inactive but could erupt again. For example, the majority of the Cascade volcanoes are believed to be a dormant rather than extinct. Classification of volcanoes based on the nature of eruption and landforms developed on the surface. First of all, shield volcano. Shield volcanoes are the largest of volcanoes. Hawaiian Island are the best example of shield volcanoes. Basalt lava flow. Fourth is lava is very fluid. They are not steep. They become explosive when water is held into the vent. Develops into the cinder cone. Next type is composite volcanoes. These kinds of volcanoes are cool and more viscous lava. They are explosive eruptions. They erupt pyroclastic and ashes along with the lava. They are formed layers. Next is caldera. These are the most explosive types of volcanoes. Next type is flood basalt provinces. They consist of highly fluid lava. Some parts of the world are covered by thousands of square kilometers of basalts. There can be series of flows. The average thickness is more than 50 km. The individual flow is 100 of square kilometer. Example, Deccan Plateau. Next is mid-oceanic ridges volcanoes. They are found in oceanic surface, more than 70,000 km length. They are frequent volcanic eruption. Example of the mid-oceanic ridges volcanoes are mid-Atlantic ridges. Next is types of landforms which is made by volcanic eruptions. Intrusive volcanic landforms. When volcanic eruption take place, some lava comes out and some settle down in the lithosphere. When lava comes out from volcanic rocks, some part cools down in the lower portion forms plutonic rocks. Next topic is intrusive forms occur inside the crust. First is batholith, a large part of the magma material that cools in the deeper depth of the crust. They are dome shaped, cover large areas. They come out when erosion takes place. They are granite bodies. Next is laccoliths. Large domes shaped intrusive bodies consist of level bodies connected through pipe like conduit from below in resemble composite volcanoes found deeper depthly are localized source of lava. Example Karnataka plateau. Next is lapoliths, concave shaped lava formation, facholiths, wave type lava formation. Next is seal, horizontal sheet of lava. And the last one is dikes, vertical lava formation.